Hello everyone, welcome back to my channel. So in this video we'll solve some more gate previous problems on Cauchy's integral formula. Okay, if you are first time to my channel, please consider subscribing and encourage me to do more videos like this. Okay, so in the previous 2 or 3 videos we have been discussing about the Cauchy's integral formula and its different types of problems. Okay, some of the problems we have taken and some of the gate problems also we have taken and solved them. Okay, so now we'll see 3 more problems in this video as well, okay, which are all gate previous problems only. So he has given in the following integral the contour C encloses the points 2 pi and minus 2 pi, then the value of this integral. So what does it mean is he has given the singularity here is z is equal to 2 pi I, and without giving this closed contour he has given directly that it includes this point. Okay, contour encloses this point means it is inside only. Z is equal to 2 pi I is inside the contour. Okay, so instead of giving the contour he may give like this also, encloses the point, encloses the point. This terminology is important. So encloses the point means it is inside the circle only. So when it is inside the circle, then you can apply the Cauchy's integral formula. So Cauchy's integral formula is given by f of z by z minus z naught whole to the power of n plus 1 dz is equal to 2 pi I by n factorial into fn of z, f power n of z naught. So now n plus 1 is equal to 3, so n is equal to 2 and z naught value is 2 pi I. So I am substituting here. So we have minus 1 by 2 pi multiplied also. So when this is multiplied by minus 1 by 2 pi, this is also multiplied by minus 1 by 2 pi. So minus 1 by 2 pi into 2 pi I by n. N is 2 now, 2 factorial. 2 pi I by 2 factorial into f double dash of z naught value is 2 pi I. Okay, so this is what you have to find. So 2 pi and 2 pi gets cancelled, so it will be minus I by 2 into f double dash of 2 pi I. Okay, so what is f of z given for you? F of z is sin z. Okay, so f of z is sin z, then f dash of z d by dz of sin z is cos z, and f double dash of z d by dz of cos z is minus sin z. Okay, so f double dash of z is minus sin z you will get. So we need f double dash of 2 pi I, so it is minus sin of 2 pi I, minus sin of 2 pi I. Okay, so minus sin of 2 pi I can be written as minus I into sin h 2 pi. Okay, minus of sin, because sin of I theta is equal to sin h theta. I sin h theta. Okay, sin of I theta is equal to I sin h theta. So using this identity we can write like this. Okay, so this will be minus I sin h 2 pi, sin h 2 pi. So if you substitute here, what you'll get? Minus I by 2 into minus I sin h 2 pi. Okay, so if you write minus into minus becomes plus, so I into I is again I squared, so you'll get minus sin h 2 pi divided by 2. What is sin minus 1 by 2 into sin h 2 pi is given by e power 2 pi minus e power minus 2 pi divided by 2. We know that sin h theta is equal to e power theta minus e power minus theta divided by 2. Similarly, sin h of 2 pi, in the place of theta you have 2 pi now, so e power 2 pi minus e power minus 2 pi divided by 2. So if you find these values, you'll get e power 2 pi value as 536.85. Okay, so you just substitute that. So we have to take pi value as 22 by 7. Okay, So e power 44 by 7 minus e power minus 44 by 7 divided by 2 you have to take. So e power 44 by 7 you will get it as 536.85 minus this will be 0.00186. If you find this value, e power minus 44 by 7 will be like this, okay, divided by 2. So you will get around minus 134.21, okay. So that is the answer here, minus 134.21, right? So the important point here why I have taken this question is encloses the point. This, if this word is given for you, then directly, because in the option, if they give as options, they will give 0 also, and you think that no closed contour is given for you, so it will be outside or inside, so we may keep it as 0. So if it is given, if the phrase given is encloses the point, that means it is inside the circle or inside the contour, okay. Right, we'll solve one more problem, right? So 2017 electronics and communication, okay, this is GATE 2017 problem for electronics and communication engineering. So he has given an integral I, and he has asked to find the value of I, and he has given some contour, okay. Same procedure. So z square plus 1 is equal to 0, z is equal to plus or minus I, so that is z is equal to I and z is equal to minus I. So contour is z minus 3, so if you substitute I minus 3, so this is 1 minus 3 which is equal to minus 2 less than 0, so this is inside only. And similarly if you substitute minus I also, you will get minus 1 minus 3 only, so it is minus 2 again, it is less than 0, so this is also inside. So first of all what you have got is both the singularities are inside the given contour, z is equal to 3. Next, so I is equal to integral c z square minus 1 into e power z by z plus I into z minus I, z plus I into z minus I dz, okay. So both are inside only, so we have to find the partial fractions. So z plus I into z minus I is equal to a by z plus I plus b by z minus I. So a is obtained just by substituting minus I here, so we should not consider this, just substituting minus I in this. So 1 by minus I, so it will be minus 1 by 2I. So b is obtained by substituting z is equal to I by not considering this, so if you substitute 1 by 2I, okay. So I is equal to integral c z square minus 1 into e power z into 1 by this total is equal to this now. So 1 by 2I you can write outside because this contains 1 by 2I, this also contains minus 1 by 2I. So it will be 1 by z minus I minus 1 by z plus I dz, okay, right. So in the place of a we can substitute with minus 1 by 2I, and in place of b I have substituted with 1 by 2I. So if you take 1 by 2I constant, so this will be plus, so I have written first 1 by z minus I, and this is minus, so I have written second. Now if you split that into two parts, then I is equal to integral z square minus 1 into e power z, okay. So 1 by 2I I am writing outside, for both it is there, okay. So I am writing outside, so integral z square minus 1 into e power z into 1 by z minus I, so this is z minus I dz, minus integral z square minus 1 into e power z divided by 1 by z plus I dz, okay. So these two are simple poles only. So from Cauchy's integral formula, f of z by z minus z naught dz is equal to 2 pi I into f of z naught. So in the first integral z naught is I, in the second integral z naught is minus I. So 1 by 2I into 2 pi I into f of I minus 2 pi I into f of minus I. Okay, so you can take 2 pi I common, so 2 pi I by 2I into f of I minus f of minus I. So 2I gets cancelled, so you'll get this pi into this. So what is f of z? F of z is z square minus 1 into e power z. So we need f of I, so that means in the place of z substitute with I. So this is I square minus 1 into e power I. So I square is minus 1, minus 1 minus 1 is minus 2 e power I. So this is your f of I. Similarly, f of minus I if you need, so we need f of minus I also, so it will be I square only, so minus 1 minus 1 minus 1 into e power minus I you'll get. So this will be minus 2 into e power minus I. This is f of minus I. So pi into f of I is minus 2, so minus 2 I will take common. Okay, so I'm writing minus 2 also in, okay, outside this, so minus 2 into pi. Okay, so minus 2 into pi e power I minus e power minus I. Okay, so minus 2 pi into e power I minus e power minus I by 2I. So I'm dividing with 2I and multiplying with 2I. Okay, so this will become minus 4 pi I into, what is this? Sine 1, because we have sine theta is equal to e power I theta minus e power minus I theta divided by 2. So sine of 1, that is theta is equal to 1, if you substitute you'll get e power I minus e power minus I, sorry, by 2I. Okay, 2I. So this total is sine 1. So your answer will be minus 4 pi I into sine 1. So option D is correct. Okay, so this is how we can solve any problem using the simple concept of Cauchy's integral formula. Okay, so you just have to check first whether singularities are inside or outside the contour and just apply the formula. You'll get the answer. Okay.